let's use the equations of motion rather than the gradient of the graph to calculate the velocity at various instants. The first two questions correspond to what we answered previously. We have to find the velocity at the instant 1 second after the start of the motion and 2 seconds. Again, of course, after the start of the motion. Time equals 2 seconds and 2 seconds after the start of the motion are the same thing. Then questions C and D are a little different. We have to calculate the velocity 3 seconds after the stone was moving at 10 meters per second and 1 second after the stone was moving at 20 meters per second. A. When we answer these questions, the first step is to define what the interval is that the question is referring to. For A and B, this is easy because it always starts at the start of the motion, so the initial time of the interval is 0 seconds. For A, the final time is 1 second, and we have to calculate the velocity at that time, at time equals 1 second. In other words, the final velocity for this interval, which starts at 0 seconds, the start of motion, and ends 1 second after the start of motion. So here's our interval, from 0 second to 1 second. So actually from here we can already see our answer. The initial velocity is 0 meters per second and the final velocity is 10 meters per second. In other words, the velocity 1 second after the start is 10 meters per second. But let's pretend we don't already know that, and let's use this equation to calculate the answer. V final equals V initial plus A t. In other words, V final equals V initial plus A, and that must be multiplied by T final minus T initial, because T final minus T initial is delta T time interval. So for this interval, V initial is 0 meters per second. The acceleration for this entire motion is 10 meters per second squared. And for this particular interval, the time duration is 1 second. T final 1 second, T initial 0 seconds. 1 minus 0 is 1 second. So V final equals 0 meters per second plus 10 meters per second squared times 1 second. 10 meters per second squared times 1 second is 10 meters per second. Notice that the seconds and one of the per seconds cancel. That's why we get 10 meters per second. 0 meters per second plus 10 meters per second is equal to 10 meters per second. For question B, the interval also starts at the start of motion, 0 seconds. It ends 2 seconds after this at time 2 seconds. V final, we already actually know from here, is 20 meters per second and V initial is 0 meters per second, but let's pretend we don't know V final yet so that we can use this equation to calculate it. V final equals V initial plus A delta T, where delta T means T final minus T initial. V initial for this interval is 0 meters per second. Acceleration for this entire motion is 10 meters per second squared, and this interval lasts 2 seconds long. It ends at time 2 seconds, T final 2 seconds, begins at time 0 seconds, T initial 0 seconds, 2 minus 0, 2 seconds. So we have 0 meters per second plus 10 meters per second squared times 2 seconds. 10 times 2 is 20. Meters per second squared times seconds is meters per second. So we have 0 meters per second plus 20 meters per second gives 20 meters per second. And indeed, that is the V final for this interval. C and D are a little bit more difficult because we have to think a little bit more when we define our interval. 3 seconds after the stone was moving at 10 meters per second. So our interval starts when the stone was at 10 meters per second. In other words, T equals 1 second. The interval ends 3 seconds later. In other words, at time 4 seconds. We can see from the start 1 second, 3 seconds pass until we get to 4 seconds. So our interval is from time 1 second to time 4 seconds. V final equals V initial plus A delta T. Now V initial is not 0 meters per second because our interval doesn't start at the start of motion. V initial now is 10 meters per second. Acceleration is still 10 meters per second squared. We already know the time interval, we told it. 3 seconds after the stone was moving. So 3 seconds after means a duration of 3 seconds. So we could really skip the step of writing T final and T initial. We could just go straight to delta T. We know delta T is 3 seconds. But anyway, let's substitute T final and T initial. T final is 4 seconds, T initial 1 second. 4 minus 1 is 3 seconds, as we already knew anyway that the interval is 3 seconds long. So we have 10 meters per second plus, and now we multiply, 10 meters per second squared by 3 seconds. 10 meters per second squared multiplied by 3 seconds is 30 meters per second. So what we actually have here is two velocities that we add. What are the meanings of these two velocities? If the stone had moved uniformly, then it would have gone at its initial velocity all the time, 10 meters per second. But now it doesn't move uniformly, it accelerates. So on top of the initial 10 meters per second, it still goes faster. How much faster? Every second it goes 10 meters per second faster, and it does that for 3 seconds, so it increases 30 meters per second during that time. So from 10 meters per second, it still goes 30 meters per second faster, 40 meters per second. So the 30 meters per second here is as a result of the acceleration, and the 10 meters per second is a result just of the initial velocity. And the final velocity is a result of both of those, the initial velocity and what comes from acceleration. And we see that indeed, 3 seconds after the stone was moving at 10 meters per second, it was going at 40 meters per second. D. 1 second after the stone was moving at 20 meters per second. So our interval starts at 20 meters per second and it ends 1 second later. In other words, the initial time is 2 seconds and the final time, a second later, 3 seconds. So this is our interval. So we can already see the answer. A second after it was going at 20 meters per second, it was going at 30 meters per second. But let's pretend we don't know that already and let's calculate it. V final equals V initial plus A delta T. So for this interval, V initial is 20 meters per second, and then it still gets faster. How much faster? AT faster. A is 10 meters per second squared. We are told 1 second after the stone was moving at 20 meters per second, so delta T is 1 second. But let's find T final and T initial and substitute it into the equation anyway. T final is 3 seconds, T initial 2 seconds. 3 minus 2 is 1 second, which we knew anyway that the interval lasts 1 second. 20 meters per second plus 10 meters per second squared times 1 second. 10 meters per second squared multiplied by 1 second equals 10 meters per second. 20 meters per second plus 10 meters per second is 30 meters per second, which is the final velocity for this interval. In other words, the time 1 second after it was going 20 meters per second.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!